This is of data analytics class with Mdth, like we echoed last class, which was yesterday. The model for you to complete these particular exercises is going to hone you in becoming a better data analyst. And so far, we are still in the introduction part to data analytics. Yesterday, we saw the skills needed for us to become good data analysts, and we saw the pathways that help us to become better users of every data analytics tool. Additional to that too, we saw how important it is for us to have soft skills as data analysts. In today's class, we are going to look into the processes of data analysis. We're also going to see the life cycle of data, and we are also going to understand how important it is that we understand these three major phases in data analysis, which will help us to set up our mindset and our spreadsheets for data analysis. So before we begin, I'd like to take our feedbacks on how our day was and how prepared we are for tonight's class. So I'll start with you, Francis. How was your day and how expectant are you for tonight's class?
Good evening, sir.
Good evening.
My day was okay. It was fine. Nothing much really. I spent most of it at home. And ready for today's class. Yes, I am. I'm prepared and I'm ready to gain some more knowledge.
Wonderful.
Yes,
Wonderful. Sir. That's very much appreciated. Well done.
Thank you, sir.
All right, so the other individuals that we are waiting for, we kickstart while we wait for them to join up on the call, right? That's very fun. So we discussed what data analytics is yesterday, and I don't know if we still remember the definition we gave to data analytics and the three measures that we highlight out in data analytics.
Yes, sir. I recall.
Can you please highlight the ones you recall?
I recall the definition of data analytics, the one that you gave. I recall the technical skills that you mentioned. I recall the soft skill, and I recall what it is we must like attribute ourselves to in order to like become a data analyst. I remember you saying we must not strive to answer the title data analytic, that it's broad and you can look for a specific niche under data analytics and become a professional under. I remember you saying, in addition, you need to create a professional data analyst resume, develop your online profile, network with data professionals, and apply for data analyst job opening, etc.
Wonderful. Wonderful. That's very wonderful.
Yes, sir.
That's very wonderful. I appreciate you remembering all these that we discussed in our class from yesterday. So now we are going to digest the processes of data analytics. And we have highlighted the 6 processes that we use for analyzing data. Now, these 6 processes emanate from the 4 other processes of data analytics, but I decided to simplify all of them so that we can have them at our beck and call. The first is the ask process. This ask process, can you please mute your mic so that I can hear myself? It seems like my voice is re-echoing in the background. Okay. The first of the 6 processes is the ask process. Now, the ask process is the stage whereby insights are derived from stakeholders using questions. Some texts call it the identification stage, where you have identified or must have identified the problem in quotes. Here, as data analyst, you see yourself being so much involved in understanding what your stakeholders needs you to do before you can even start every other process of analyzing data. In the ask process, you tend to get insights from your stakeholders. That insight I get from stakeholders is to understand their pain points and how you can be of assistance using data. If those insights are not gotten from your stakeholders, it will be very hard for you to actually understand how to tackle their problem. And it will also be hard for you to know how you can channel your timeline of the project to answer the question of the stakeholder. Additionally, to be hard for you to know what type of data that is needed for the project to become. But when you have understood the ask process, it is much easier to work around every other stages of data analytics. The next process of data analytics, after asking questions, after understanding what the stakeholder demands of you, after using questions to know what you are expected to do as an analyst, now for you to prepare, it means that you are able to build timeline. You are able to collect data and you are able to store that data. What do we mean by when we say building timeline? Building timeline is just the same thing you do when you want to embark on a particular journey. In that journey, you will tell yourself the necessary things you need to become successful by embarking on such journey. It might be that you want to need a pot of rice, or maybe a full bag of snacks. You also will need possibly a tent if you're not going to lodge in a hotel or motel, or maybe you're entering in a particular adventure that needs you to hang in on some nets. Additionally, too, it will also help you to also plan ahead of the things you will need in the journey. There, you also see yourself working out your time to make sure that you don't miss any terrain while you are working on such adventure or journey. Additionally, you tell yourself that particular journey of mine will be for a particular number of days, say 2 days or 3 days. So if it's 2 days or 3 days, this is what I need, this is how I'm going to spend them, and this is what I expect at the end of those journeys of mine to become satisfied with what I have done. This analogy is equivalent and similar to what you do as a data analyst. As a data analyst, you tell yourself when to collect the project, how to collect the project, where to collect the project, and what type of project information you need. Let me rephrase. As an analyst, you tell yourself where to collect the data. Sorry, I used project before, so it's data. Where to collect the data, when to collect the data, how to collect the data, and what type of data you need for such projects. When you have understood this particular fake questions I just listed out, it will help you to now build a proper time frame, proper duration, proper period. If collecting the data will take you 2 to 3 days, knowing where data is located is important to bear in mind. If it's going to take you just a day, knowing how best to collect the data is also important for you to understand. When all these are being put in place, you can then tell yourself, right, I have gotten all the data I need. Let me now tell myself how long it will take me to clean the data, prepare that data, process that data, and then start analyzing to draw out insights from the data I have gotten so far. When you are telling yourself all these things, when you are building all these durations, periods, processes, in order for you to know that this particular project I'm working on as a data analyst is going to last for either 6 weeks, 8 weeks, 10 weeks, 12 weeks, or thereabout, you will focus on making sure you deliver all necessary deliverables at the end of the project. And when that is understood, it will help you also to know how best to store your data, where to store the data, and where the data will be stored. This leads us to what is called types of data. We have different types of data that we encounter in data analysis. These types of data are not different from what you know from the usual type of data we have in mind. And this type of data also emanates in other kinds of data we also have in the data industry. In general, there are two main categories of data. They are qualitative data and quantitative data. Qualitative data are those data sets that are non-numerical. They are just descriptive. Mostly they are used to describe characteristics. You cannot perform any mathematical calculations on that type of data, but you can actually take frequencies of that data. And quantitative data is very crucial in some data you are working on or some projects you embark on. The next is quantitative data. Quantitative data are those data sets that are numerical in nature. Those data sets that can be measured or even counted or can even be used to perform some mathematical operations on them. Those are quantitative data. Under the quantitative and quantitative data types, we also have other kinds of data that emanates from them. Now, let's come to the first one, qualitative data. Under qualitative data, we have what we call nominal data and ordinal data. I am very happy that I have statistician, chemistry students in my midst who understands at least 70% of any terminology I'm using in class tonight. Nominal data, which is other kind of data that emanates from qualitative data type, is used for labeling variables without any kind of order. So we are not saying 1, 2, 3, 4, 5. We are not saying fair, big, bigger, biggest. No. What we are saying here is they have no actual order. Example of nominal data sets or data type is hair color, marital status, gender. This type of data does not need you to order them in any manner. That's why we call them nominal data. But ordinal data has a natural order. That is where you see some things like what we call a Likert scale, a 5-star rating. 5-star rating and Likert scale and even position is an ordinal data because they have orders. They are arranged in a natural and meaningful order, unlike the nominal data that is not arranged in a natural or unlike the nominal data that is not arranged in a natural or meaningful order. Now, let me explain what we mean by the examples we just gave. For instance, if you are taking a survey or a feedback from some individuals on what is happening around them in their neighborhood, your survey might consist of these 5 little scales: very satisfied, neutral, dissatisfied, or very dissatisfied. It might include strongly believe, very strongly believe, no option, do not believe, strongly disagree, or disagree. This has natural order because it's a feedback and it is very meaningful. Hence, it is ordinal. The next example I mentioned is that of positioning. We know in secondary school, in primary schools, we have ordered positions such as first, second, third, or fourth. Now, this type of data sets that we are just mentioning, we can collect them in our process of preparing data. When we understand the type of data we work with, it will help us to know where best to store them. Quantitative data sets, which are numerical values that can be counted or measured, are best stored in relational databases. And we give examples of quantitative data types, such as discrete data and continuous data. Now, what do you mean by discrete data? Discrete data are those type of data that can only take a certain fixed whole value. It doesn't go with decimal places or fractions. It's a whole number. For instance, age. So you cannot say I am 20.5 years old today, or I am 21.9 years old today. No, you are either 20 or you are 21. You are either 21 or you are 22. So there's nothing like 20.5 years old today. And you cannot say that this family is made up of 4.5 members. Who is the half? Right? So those are not examples of discrete data. Rather, examples of discrete data are such data that can be rephrased from the previous example. Say someone is 29 years old, someone is 30 years old. Those are discrete type of data. They are fixed and can only take whole values. Continuous data also emanates from quantitative type of data, is the type of data that has or takes values within a given range. For instance, somebody's height, the temperature of the individual, and the time of success or failure of a project. All these can be measured in decimal places because they are continuous in nature. Someone can be 5.6 feet tall, 6.2002 tall, 2.02, 6.5 tall, 4.5 feet tall. These are all continuous data. The temperature of an individual can also run at 10.56 degrees centigrade or 7.54 degrees centigrade, as the case may be. Because that this particular range of data is continuous, we call it continuous data. Now, have to understand that we have two major types of data, which are qualitative and quantitative data types. And we have also seen that this type of data we have also have their own subtypes, which emanates from them. I have mentioned that for qualitative data type, it has other data types that emanate from it, such as nominal or ordinal data. For quantitative, it is discrete and continuous data. When a data analyst understands the type of data he's working with, it will be easy for him to know where they are stored. Now coming back to my initial statement of relational databases and non-relational databases. For relational databases, that is where we store all quantitative data types. All quantitative data types, you store them in relational databases. And you might ask, what is relational databases? A relational database is a database that is made up of a structured rows and columns. Structured rows and columns. That is what makes a relational database. So by default, humans store data in relational database. No wonder in your class attendance while you were in school, if they want to take attendance, they tear sheet of paper and they have serial number, name, and possibly a rate. You write your name, first row, another person on the second row, next on the third row. Maybe up to 50 persons will write their attendance. And at the end of the day, you will have just 3 columns of data that has 50 rows. Such type of data is a relational data set or database, which can be typed into your spreadsheet. And with that method, you have stored it as a local storage facility for your data set. But for non-relational database or unrelational database data, we talk about data sets that are metadata. Metadata. Now, what do you mean by metadata? That is data sets, information about information, data about data. To explain this, we have our WhatsApp discussions, our email discussions, our video discussions, such as this, audio discussions, and other interactions we do on social media. Those discussions we have with people on email, on social media, on calls, and the rest of them are called unrelational or non-relational data types or databases. Why? Because those type of informations you have are not stored in rows and columns. They are not stored in rows and columns. Rather, they are stored in texts, MP3 formats, MP4 formats, and the rest of them. Hence, we cannot say that they are relational databases. That's why we say that qualitative data are data sets that describes other characteristics. It does not lead to measure or lead us to calculating mathematically. As a data analyst, you must understand these types and kinds of data and also understand the different storage we use for them. When you have collected those questions from your stakeholders and they have given you insights from what you need in order to embark on the project, and you have built your own project timeline, collected the data sets, for you to now determine where and how data will be stored, you must understand these data types, kinds, and storage mode that we just mentioned. When these are all understood, then you can proceed to the next process of data analytics. And that process is process. In the process, we talk about cleaning the data. checking that the information you've collected is in alignment with the objective of your analysis. Here, you will hear the word data cleaning. You will hear the word data analysis. You will hear the word data transformation. You will hear the word data wrangling. All these fall into the process of data analytics. You see yourself looking out for errors, looking out for duplicates, removing blanks, making sure that every data is in each required data type, making sure that every data set, every column, every data information is in each consistent data site. Now, we are doing that, we call it data bending in a fun language. Data bending, that's a fun language we use. It's not easy to process data, right? It's not easy to process data. Now, having understood how well it is to process data, the analysts move forward to drawing all the necessary conclusions. Drawing all the necessary conclusions. Now, how does he do that? While he has actually removed any inconsistency, remove all the duplicates, remove the nulls, make sure that every data column in the table corresponds to each data types, and every transformation needed to achieve a particular aim is on check. He will start looking out for patterns, relationships, trends in that data that he has processed. This is where modeling of data comes in. This is where checking out for information alignment with objective comes in. This is where we now start thinking, how do I actually answer a question using the data set I have? This is where you start thinking, which particular column, which particular table answers the question of XYZ ABC? And when you are doing that, you are trying relationship with those tables you have in your data, and also use it to find out the progression of action that happens along the line. Those progression of action tells you a trend in that particular analysis. For instance, you analyze XYZ cells, and in that XYZ cells, notice that a particular product called electronic segments are always topping both in revenue and in profit. The next 3 years to come, you also analyze the same XYZ set, but this time around a newer data set than the previous one. You also notice again that electronic segment is also topping the chart in revenue and profit. In that regard, you have noticed that the trend is serial between these particular electronic. It can still be the same after the next 2 years, that same electronic segment will still be topping the charts when it comes to revenue and profits. When this happens, it helps you see that, wow, actually, there's a trend that this follows in a particular time frame. And from this year to this year to that year, I've noticed that electronic segment is always topping the chart. What might be the cause? What the pattern that is going to unveil if I should drill through it? Then you start looking out for what might actually cause the segment to always top the chart of your sales and revenue or profit made in those previous years that you worked on. With all those on check, it will help you to become a better analyst and a wonderful individual at the end of the day, which will lead you to draw relevant conclusions after all this process has been achieved. Now, when that is done, you will now share your insights, that conclusion you have gotten from asking questions, preparing and building timeline and data, processing and analyzing your information, getting all the necessary information and conclusion you need for the analysis and the project. You will now share it to the stakeholders, who are your audience. And at the end of the day, it is expected that they act on the data and use that analysis result you've made to make data-driven decisions. Remember, at the end of your analysis, you are going to still tell your stakeholders that we are to implement ABC strategy for us to get XYZ results. That is a recommendation after your conclusion. It is not less for them, who are your stakeholders, to know whether they are going to act upon that result or not. Obviously, statistics have shown that most of the recommendations that are derived from the conclusion of data analyst in every company yields up to 70% good results for any company or stakeholder that actually works with those recommendations and insights. Now, these 6 processes of data analytics are go-to for anybody who is into this data industry, be you a beginner, intermediate, or professional advanced stage, because we cannot let go of these step-by-step processes. Remember, one of the core major soft skills a data analyst must possess is analytical thinking. He must be able to identify a problem, define that problem, and then solve that problem in a step-by-step manner. And we've listed the 6 processes that helps a data analyst to work on this particular aspect of his skill. At the end of the day, the data you've collected will need to become alive. Yes, data can be alive. Data can be living. Why do you say so? Because everything that has a beginning must also have an end. And because it is something that is alive, because it is something that has a beginning and also an end, you can use the term being alive for data. This leads us to what we call life cycle of data. Data, data, data. You can use an instance of trend to define this life cycle of data. I remember the time when BlackBerry almost killed the youths of Nigeria. Now, that time that BlackBerry was trending is his own duration of livelihood. But the moment BlackBerry was overthrown by Android, the likes of Techno, the likes of Infinix, the likes of iPhone, iOS, and the likes of Samsung and even Itel, they knew BlackBerry any longer. That is because it has reached its peak of relevance. Therefore, it needs to go away. Something happens to when we are in the phase of the pandemic. That situation that we stayed in our house for almost 1 year was terrible to a lot of persons, but it still came and go. It has its own stage, and that stage determines the process or duration it will take to last or not to last. Same thing goes with the academic sector or any journey you're embarking upon. There must be a start and there must be what? A finish. The same thing goes with data. Data lifecycle defines the start and finish of a data journey. The start and finish of a data journey. It helps us to define how our data starts and how it ends. And the first stage of it is the plan stage. The plan stage. In the plan stage, this is what is similar to the ARC stage, ARC process of data analysis. Here, you as the data analyst decides what kind of data is needed and how it will be managed. refer back to asking questions in data analysis, right? Also refer back to types of data and the kinds of data that emanate from the types of data we discussed. Also reflect on the storage phases of those types of data we have also discussed. They are all in line with the plan stage of the data lifecycle. After the planning stage, you see yourself trying to get the data from different sources. That is where you now build your timeline in the prepare process of data analysis. In the capture process, you see yourself bringing from different sources data and information. When you are doing your final year project, you can remember or recall that it was not just in one particular source that you got your information. You tend to go through various sources. Sometimes it requires you to take a whole lot of your day only to go to different places to get data sets. Sometimes too, it requires you to browse almost the whole internet search engines for you to get what you want. To say require you to Google a lot of journals so you can get the right source or the right resources that answers your question. That is what the capture stage comprises of. And when you have gotten those data sets, you've gotten those resources that you need to start your project, and you've actually determined where to store them and who will be responsible for them, you now store them in a place where they will be carefully maintained until the time of usage. Some persons who work on projects tend to start browsing or Googling for resources or going to various places to get the resources they need on time, even before the project kicks off. Once they've received their project topic, they will start going through to get to resources. And when they get it, the next thing they do is to store it in their laptops or they store it in their phone, and they store it in a folder that in that folder, nobody will tamper with it. Like nobody dares tamper with that folder. If somebody wants to tamper with that folder, the person will be penalized because you want to make sure that this information you gathered so far for your analysis or your project will not go to waste. You must finish with it before anybody else can try to tamper with it. And that is why when someone mistakenly wipes out a particular journal or document from our researches we've made, you'll be so furious because sometimes we might not even bookmark that website or bookmark where we got the resources. And sometimes we even forget the author of the book or journal you've collected. So that thing you are doing to safeguard those information you've gathered, to make sure that nobody tampers with it, is what we call the managed stage of data lifecycle. In that stage, you care for and maintain the data, knowing fully well that if any information or any singular material is pulled off from what you have at your disposal, it might make or mar your research. Now, after all this is being taken care of, you see yourself doing the next stage of data, where that will now be moved to the analyze stage. In this analyze stage, you use what you've gathered so far from those data to solve problem. The same thing that happens in the analyze process of data analytics also happens in the life cycle of data in the analyze stage. And once a data set is being fully and completely analyzed, you also see that it has been used. Nothing is left again. It has been used to the fullest of it all. And you can attest to the fact that your stakeholder or your client is happy with the results that was gotten from utilizing your research. What then happens to the data? They throw it away? Of course not. They will only archive it. They will store it for long-term future references. In case they encounter a similar problem like that in the future, they will know how to tackle it. They will use what they have done before to do the next stage of the problem that might arise when the case comes. This is why we have references in our projects. References is not that we cannot do it ourselves. No. References is that we have seen people who have done something we've done before. We want to do something, but yet there might be a gap in what they did from what we are about to do. Hence, we want to use some insights they have gotten from their own project, which is similar to ours, add it together and see how we can modify the process. And after we are done with our own projects, somebody somewhere too will still go and take our project as a reference to do his or her project. If there is no archive, if there is no storage of data, you and I will not be using the word statistics have shown that or evidence have shown that. Those kind of statements will not be occurring in our talks. Because we have those data stored for long-term use and for future references, we can purposely and in full chest say statistics have seen, evidence have seen, record also shows, etc., etc. That is where you come in as analyst. After the data has already been prepared, analyzed, shared, and acted upon, your next job is to archive it. That is why I see that most times if you want to go to some of these free platforms that give you wonderful data sets for practice and portfolio building, you see them downloaded in a zip format. Why didn't they just open it now so that it can be in Excel or CSV format or maybe in a PBIX format? No, because you want to maintain the originality of the data, maintain the integrity of that data, we store it on a zip compressed folder. But on the long run, you notice again that that data that you stored is no longer in use. It doesn't longer require you to use it really doesn't make sense any longer. For instance, some practices that health professionals do in 2025 is not the same that they did in about 2,000 years ago or about 500 years ago. The industry has evolved. It has innovated. Some practices and methods of acquiring a particular mode of healthcare problem solving is no longer in place. Hence, they tend to discard those practices that were used before. In that regard, we say that the data is destroyed. Here, no need for it again. It has been done with, and we don't need to have it at our archive, in our library, or anywhere. These stages of life cycle of data we have just discussed helps you, the analyst, to work simultaneously in analytical sense with the data so that you don't end up being so much a loser at the end of the day. Remember, all these stages and process of data analytics has majority of soft skills in it. It takes someone who understands managerial skills to know that when I download the data resource, I must store it in a place it will not be spoiled or tampered with. It's also taking managerial skill for someone who is an analyst to know that at the end of the analysis, after conclusion and everything has been made and the action point has been acted upon, I need to archive it should in case of future references. It also takes someone who is a data analyst to understand that creativity is involved while telling the story of the problem and in that regard, every analyst must utilize all necessary skills and arsenals he needs to make sure that he delivers his project as at when due and in a very wonderful manner. Now, we want to discuss how a data analyst can become very fair and impartial while using his data. What do you mean by becoming fair and impartial? What we mean is that every data project we are embarking on must encounter unforeseen occurrence. Now, what are those unforeseen occurrences? It involves biasness. It involves prejudice. That is why up to date, when you go to the Google search engine or Bing search engine, and you want to Google about an African man, you always see some wretched, poverty-ridden individuals. But thank God for the innovative mindset we have today. At least, when you go online to browse for African man since 2024 till date, you notice that there has been a change in some images you see in your data. And those changes help you see that, yes, actually, there is innovation in process. And actually, as well, that people these days are understanding the essence of being very much fair and impartial while working with data. Now, all these things tie down to a single word called data integrity. Data integrity is the ability where a data or group of data which is being used for analysis is valid, complete, authentic, consistent, and does not change between resources, sources, and destination. Notice the point. It means data integrity means that the data is valid, complete, authentic, consistent, and does not change between source, resources, and destination. It is why it is important that after you must have finished your analysis, you need to archive it, zip and archive, in order to retain its validity, its authenticity, and it must not also change between sources. And what do you mean by does not change between sources? Some data, which are mostly relational data sets, which are also being stored in relational databases, do not change when they are being stored. Because when you notice that a data is stored in a database such as SQL, maybe a MySQL database or a PostgreSQL database, data set, when you still go to that database to download it, it is still the same as it should be in the original file. The type doesn't change. The kind doesn't change. Additionally, too, you also notice again that it is still valid for the projects you want to use it for, which is also similar to the project that has been used before. So when data is all of this, we say that that data maintained integrity. Then when data is full of practical and valuable information for your business stack, we will say that the data is full of quality. Sometimes a lot of persons have engaged in a situation whereby the data they have collected for their resources, for their research, for their project, do not answer their question, are not even valuable. You might end up hearing the word, why did you go and take such data sets when you know that it will not solve your problem? Do you think that this particular data set is in line with your project objective? Right? So those kind of questions that comes up from your professors, your doctors, your stakeholders, or your team members is because the data you choose does not contain the information for the task you are embarking upon. In that case, you have committed an error in data quality assurance. Hence, to avoid such error, you must make sure that your data is full of practical and valuable information needed for your business tasks or for any other tasks at all. You must work on your project of work. Why are these things important? Why are we reminding ourselves all these things? They are reminding ourselves of this because it saves us time and effort and even the costs that can arise from making incorrect or incomplete data results. Imagine that you are done with a particular project and you are meant to spend maybe $100 and you end up spending $200. Yet, at the end of the day, you notice that all those time and resources and efforts you have spent still requires you to spend more because the data you've collected does not serve the quality that is needed for your project. Then is a big problem very, very much. The next, it helps you to make higher impactful decisions, and those decisions will be beneficial for the industry. That is aside protecting your image and that of the company as well. Because when you have an error that arises from you being a bad data analyst, it will result to the point whereby everybody who is called a data analyst might not even have a chance to venture into that industry. So it's important that you make sure that your data is full of fairness and impartiality. The third of it is that it ensures transparency and trustworthiness of your data. It ensures transparency and trustworthiness of your data. Notice that when your data is practical in nature and it contains all the authentic and consistent method that can help you to become very much a valuable analyst, you end up being a very trustworthy analyst that even your stakeholder can recommend you to other industries. So you see, it's important that you utilize this fairness and impartiality in your data analytics journey. So far, we have discussed the most important things that we need to have in mind in these introductory classes of data analysis. We have seen that it is important that we harness and utilize those 6 processes of data analysis. We've also seen and also understood that it's also important that we utilize the life cycle of data, making sure that we skip no stage while working with data. We've also seen how important it is for a data analyst to make sure that the data he or she is working with is full of integrity, quality, and fair judgment. When you utilize all these things in your skill as a data analyst, you will be a go-to individual when it comes to analyzing data in any industry of choice. Did I forget that we've also mentioned the types of data we have, which are qualitative and quantitative. And from these two types of data, we've also seen that there are other subtypes that emanate from it, such as ordinal or nominal, discrete, and continuous. We've also seen how important for us to understand data storages and what type of data fits into a particular storage. For instance, if you have a quantitative data, which is either discrete or continuous, it is best to store them in a relational database, which is made up of rows and columns structured in a way that can be readable in a table format. But if we have a qualitative data set, which is either nominal or ordinal, we don't talk about storing them in non-relational databases, which will help us to access those informations as at when due. Those things we have discussed this night and this day, which is the day 2 of our class, are the things we need to bear at the back of our mind, because we are still going to meet them when we venture into the practical aspects of our class going forward. Therefore, we encourage you, I personally encourage you, to sit tight, because the journey of your data analysis has just started. It has just started. Therefore, I will always tell you, brace up. It is now that you have entered the full gear of a data analyst, and we are not going back. No, we are not going back. We must keep riding this journey and this particular industry till the finish of it. Until we are satisfied at the level we will be, then we will say we can stop and pause and breathe. But mind you, if you continue, you will still be facing some challenges on the long run, especially in the practical aspects. But don't allow that to sway your motion. Don't allow that to sway your zeal, your enthusiasm in learning about data. Develop tenacity, and you will actually succeed in this tech field of data industry. On the day 3, we are going to discuss how we are going to set up our data analytics toolbox. In that day 3, we'll be introducing us to the use of Microsoft Excel data analysis. In that same day 3, by God's grace, we're also going to see how we can structure and customize our spreadsheet in order to look very, very much ready for analysis. Remember, we are following our course paths serially as it's supposed to be, and that will help us to usher us into data entry, formatting, and organization of data, and the other ones we have in our schedule. So thank you very much for joining the call today, and we really please, you can ask your question now from what we discussed in the past 58 minutes.
Yes, sir, from me, there's no question, sir. You put everything in a very understood. You put everything in a very cool manner, so I understand most of it.
All right. Thank you very much for understanding all that we've said today. Seems network is disturbing a lot of persons tonight, but I believe before tomorrow, when recording of tonight's class is being dropped, they'll see the video and then follow up from tomorrow on day 3 of our classes. So thank you very much for joining on the call, and see you tomorrow. Expect your first week or the week one assessments to be dropped during the weekend as well. So brace up with all we've discussed. Go to the readings we shared with you, refresh your memories on them in order to answer properly in the questions we asked in that week one. Because basically week one is all about these introductions we've been doing so far, while from week two we now kick off practical sections that will help us to become so good with using data analysis tools. So thank you very much and have a wonderful night's rest.
Okay, sir. Thank you very much, sir. And you too, sir.